start by gathering our supplies. For all three experiments, we will be needing a blown up balloon and something made out of wool. This could be a blanket, a scarf, some socks, or even a hat. But if you don't have anything made out of wool, don't worry. You can actually substitute and use your hair or someone else's. Additionally, for our first experiment, we will be needing tissue paper, scissors, a pen. For our second experiment, we will need a paper cup and a pencil, but you can also just use your sink and faucet. For our third experiment, we'll need an additional blown up balloon and some string. And as always, don't forget to grab a grown-up. Before we get started and see static electricity in action, let's first learn some of the science behind how it works. Static electricity is the buildup of an imbalance of electrical charges in an object. When one object is rubbed against another, static electricity can be created. This is because the rubbing creates a negative charge that's carried by electrons. The imbalance is created by those extra negative charges being attached onto the object. When enough electrons build up, they can produce static electricity. You've probably felt static electricity throughout your life. When you rub a balloon on your head, it causes opposite static charges to build up both on your hair and on the balloon. So when you pull the balloon slowly away from your head, you can see those two opposite static charges attracting one another and making your hair stand up. Static electricity can actually cause objects to cling to each other or attract each other. This happens when objects have opposite charges, so one has a positive charge and one has a negative charge. And when they combine, they'll attract each other. But when static electricity is applied and the objects have the same electrical charges, so a positive and a positive or negative and a negative, they will repel each other or move away from each other. For all three experiments, I asked you to grab something made out of wool. This is because wool is a conductive material, which just means that it readily gives away its electrons easily. When you rub your balloon on the wool, this causes the electrons to move from the wool easily onto the balloon. The rubbed part of the balloon will now have a negative charge. Objects made out of rubber, like our balloons, are actually known as electrical insulators, meaning that they resist electrical charges moving through them. This is why only the part of the balloon where you rub against the wool is going to carry that negative charge. The rest of the balloon is going to remain neutral. Alright, little scientists, let's start off with experiment number 1. For this experiment, we'll be using the power of static electricity to create a wiggly snake and some jumping people. But you can always make whatever kind of design out of your tissue paper you would like, and then make it jump with our static electricity. For the snake, we'll first have to grab a large bowl, or you can just freehand a large circle. But I'm using this bowl to just trace a circle. You want to make sure that you're only using one piece of tissue paper and not 2 pieces or more. That will be too heavy for static electricity. Once you have your circle traced out, you're going to take your pen, making sure not to press too hard on the tissue paper or else you can rip it. We're going to start from off to the side, and we're just going to create a swirl that will be our snake. Doesn't have to be perfect. Since we'll be using scissors to cut out our snake, make sure to grab a grown-up to help you. Make sure when you're cutting out your snake to be gentle with your tissue paper and to get it as even as you can all the way around. Once you have your tissue paper creation made, you can start grabbing your balloon and rubbing it against your wool object or your hair to create your static electricity. For this, what you want to do is make sure you only rub in one direction. If you rub back and forth, you won't get as many electrical charges onto your balloon. So rub your balloon pretty hard against your wool object or your hair in one direction for about a minute. You want to make sure you get a lot of static electricity built up onto your balloon. Let's see if we built up enough static electricity. Next, you're going to take the part of the balloon that you created your static electricity against and wave it around your snake and see if we can get it to jump and dance. Whoa. Now that our tried our snake, I'm going to try out some other figures that I cut out of tissue paper. First, we're going to try our little people, and then we're going to try the smaller butterflies and see, since these are smaller, if they'll jump higher. You can see that they're not jumping. Let's charge up a balloon and see if we can get that static electricity to get them to jump. So remember to swipe in one direction, that way you'll get the best kind of electrical charge. And remember to ask a grown-up if you need help. You want to rub it for about a minute. Alright, I went ahead and charged up my balloon, and now let's see if we can get our people to jump. Ooh, there's one. But our butterflies immediately start flying. So it looks like the lighter and smaller the tissue paper figures are, the better they'll jump. Got one. This one wants to dance. We learned earlier that one object has a positive charge and one object has a negative charge, so they have opposite charges, they attract each other. And that's what we can see here. Let's move on to our second experiment. Experiment number 2. For this experiment, we're going to grab our paper cup and put it upside down. Next, you're going to take your pencil, but be careful, it's going to be sharp, and poke a hole right in the middle. And you want the hole not to be too big like this one. What we're looking for is to have a small, steady stream of water just like that. You can always use your faucet for this step, but you basically want it to be at a low setting so that you have a water stream that comes out steadily and small. If you are using a paper cup, make sure you have something to catch the water. What we're looking to do is to bend our water and make it flexible with our static electricity. Next, what you're going to do is charge up your balloon just like before. Make sure to rub in one direction to get the best electrical charge for about a minute. Once you have your balloon all charged up, we're going to grab our water and pour it in our cup so that we have our steady stream. Next, you're going to take your balloon and then place your balloon close to the stream of water without touching it. Didn't work. Let's see if I can charge up my balloon more and see if it works. This time I'm just going to grab a little bit of water and let's see if it works. It kind of does. Okay, so it kind of works. You want to make sure when you're doing this experiment that your balloon isn't touching a stream of water. It's just very close to it. Water is composed of one oxygen atom and two hydrogen atoms that share their electrons unequally. This causes the hydrogen atoms to carry a slightly positive charge. When the balloon is held closely enough to the water, the slightly negative balloon is going to attract the slightly positive water, making the stream of water bend towards the balloon. But as we can see with our experiment, it didn't quite go as well. We got it to bend just slightly, but not too much. This is because it's currently summer and the air is slightly humid. And if the air is too humid, water molecules in the air will actually stick to the extra electrons on the balloon. This takes away its static charge. And I think that's why my experiment didn't work. But that's what science is all about, seeing what works and what doesn't. I hope you little scientists do this experiment at home and send us a picture or video if yours does work. Alright little scientists, time for your third and last experiment. For this one, we're going to take our second blown up balloon and we're going to measure out two pieces of string that are equal lengths. You can always ask a grown-up for help, and we're going to tie that string to both of our balloons so that they hang right next to each other, just like this. And as we can see, when we hang two balloons right next to each other, nothing happens. But let's see when we add static electricity to the mix, what will happen. Next, you might want to grab someone to assist you with this part. You're going to take both your balloons and equally charge them up. Now, you want to make sure with this experiment that you charge the balloons all over the surface. Not just stick to one side, but try to get most of the balloon. That way you have enough of a charge to repel each other. And I highly recommend that you have another person help you with this one. That way you each can take one balloon and charge it up equally so it's charged at the same time. This part might be a little tricky if you only have one piece of wool. That's why you can use your hair as another one. So I'm going to charge up my balloons and we'll be right back. Now that I have my two balloons hopefully charged equally, when you put them together, they should, well, they should have repelled each other. So with this experiment, we were looking to get our balloons to repel each other because they would have had the same charge. But it looks like this experiment didn't go as planned. And that's all right. What do you little scientists think went wrong? Maybe I didn't charge them up equally. Maybe because I used my hair for one and a piece of wool for the other, the amount of electrical charges that were produced by the balloons didn't equal out. Well, that's all we have time for this week. Bye!